Hi, I'm Bert. I'm the CEO of Tanktwo, and here at Tanktwo we strongly believe in the future of the electric car. We really think that it's one of the greatest opportunities of this era, and it will certainly be up there with the invention of the PC, with the wireless telephone, with the internet, things like that. It's no coincidence that a lot of inspiration for the Tanktwo system has come from these technologies. And anyone who has driven a Tesla Model S will agree that electric cars are also a great opportunity for consumers. On top of that, there's of course also a lot of new things for business that are going to come around. So many new business models that currently don't exist, they will be made possible by electrification of transport. And we'll do our share to make that happen. And of course, there's another example that can be referred to about where the electrification of transport is a very clear benefit. Just think about once when the overhead lines are in place for powering the electric locomotives, yeah, of course, everyone uses them, and nobody's going to question that that was the right way to go about it. So for cars and trucks, of course, you cannot have overhead lines. So just once when the power of the power source, the batteries in this case, are taken care of, it will be one-way street. Nobody will question whether or not that was the right way to go. You may or may not believe that there's such a thing as human-caused global warming, or if we have already passed peak oil, but most people do agree that if a better, cheaper technology becomes available that also happens to be emissions-free, the market will vote with its wallet. And we're pretty sure that nobody really will miss the oil changes or the spark plug wires or the check engine light. So at Tanktwo we make batteries for electric cars. We introduce intelligence, so we make smart batteries, and even more so, we introduce the intelligence at the cell level. You could say that we put a smartphone in each individual cell. A lot of smart software makes it possible that the efficiency of the system is so much higher than a regular dumb monolithic pack, so that the efficiency can be 20 to 50% more than regular, in some cases even more. But more importantly, the Tanktwo battery pack capacity is flexible. And what that means is that you can have a battery pack which supports daily driving needs, say for example 20 kilowatt hours. But when the need arises, for example, you want to do a road trip, the capacity of your battery pack can be boosted temporarily or permanently if you so choose. And if you reduce your battery pack capacity afterwards, you only pay for the period that you actually had the extra capacity in use. So Tanktwo is a technology licensing company mainly, but we also operate a back-end system because safety and security requires an operator or a provider of trust, and that's a role that we fulfill. Our go-to-market strategy is to introduce a showcase product, and what that means is that we will demonstrate an actual Tanktwo-powered electric car in the beginning of 2017. We're currently on track to hit CES in the beginning of the year. And financially, we are preparing for an A round to scale operations. And the Tanktwo string battery is the first real implementation in this field of large-scale data science. For example, the string cell, what we call life cycle index, is a set of scores we compute on an ongoing basis. The index is derived from a large volume of historical data from current, voltage, shock, and temperature sensors, in addition to several other sources. It allows us to extrapolate and forecast expected future use and future value with a constantly improving accuracy. Tanktwo makes a series of analysis and simulation tools for the purpose of pre-evaluation of implementation options for customers and also for internal use to test new algorithms for routing, sorting, power optimization, things like that. The electric car market is just around the corner, which is what many say. However, if we look at what the early adopters have been willing to pay for non-conventional vehicles, such as for the Nissan Leaf or the Toyota Prius or the Chevy Volt, it indicates that early adopters can be persuaded to pay $25,000 to $35,000, but after that it gets a little difficult. And the Tesla Model 3, which everybody, including myself, is very much looking forward to, has been rumored, or as even said by Elon Musk, to be priced at $35,000 base price before taxes and incentives. And turns out that, well, that is still rather expensive. The drawing on the right here is a rendering that I've borrowed from auto-moto.com. It's a website that has done an artist impression of the Model 3, and actually I really hope that it looks like this because I want one. turns out that $35,000 is still high-end car category in most markets. And if you look at the sales statistics for North American vehicle market, so not including SUVs, trucks, and minivans, so regular cars, if you take the sales statistics, which I've taken here from goodcarbadcar.com, and you multiply those sales units, those sales figures, with the listed base price as of today, which is February 2016, you end up with a histogram that looks as follows. And yeah, it's very obvious here, right? So that the Tesla Model 3 should actually still be a lot cheaper in order to hit the sweet spot that everybody is looking forward to. Currently, no solution exists to make the electric car sufficiently affordable so that it could be called truly a mass market product. But Tanktwo will do something about that. And to make things worse, so the price of the raw material of the battery, lithium in this case, has been going up all the time. The all-time low price, which is about a year ago, of approximately $11,000 per ton of high-grade lithium, all the analysts seem to agree that that's not coming back. And even at today's prices, so the share of the raw material, the active material, lithium in this case, is already significant. So it's in several tens of dollars per kilowatt hour. So making the price erosion that everybody is looking for, is hoping for, even harder to achieve. Yeah, what the prices is concerned, so if you're a tier 1 player and you buy about 1 billion cells, so it appears that $145 per kilowatt hour is what you're going to pay. So from statements that General Motors and some other players have been making publicly lately. Very aggressive price erosion targets, not in the least because of the Tesla Gigafactory that is being set up in Nevada right now. Everybody hopes that around $100 is what we're going to be at in 2022. But still, price erosion, of course, is always welcome, and we very much welcome what is being done. But it turns out that we're still about $5,000 short of what the market is willing to pay. It's a simple sum, simple math, as you can see here on this slide. And it's this $5,000 gap that we are trying to close. And there's also news from the regulatory side. So the Paris Climate Conference, which was held a few weeks ago, had some interesting news, and that is that the upcoming tightened emissions targets will make it very hard for any manufacturer of traditional combustion engines to produce products that will comply with those new regulations. As a matter of fact, many OEMs have said that there are no known internal combustion engine technologies at their disposal which they can use to actually hit that target. So therefore, quite a few have already also explicitly said that they have no choice but to include a certain number of electric vehicles in their product mix. Without that hitting their fleet-wide emission targets is not possible. Then there's the issue of government subsidies. Government subsidies have been absolutely essential to get the industry to the point where it is today. And billions have been spent already, and many billions more will need to be spent. It's not so that there was a lot of greenery involved, meaning that those things were done for ideological reasons, but essentially there weren't really that many tools in the toolbox of governments which they had at their disposal to hit the internationally agreed emissions targets. We are at this point where nobody really can afford to subsidize electric batteries or electric car batteries into the mainstream. So a technological solution and a business model solution is necessary to get there. And this is what we do. A little known fact is that most trips are actually rather short, and it's very easy to get to that conclusion if you, for example, divide the average 12,000 miles that are driven on an annual basis by 365, you end up with 33-ish miles in total. So Tesla Model S has a range of about 10 times that. And even though, all the studies say, pretty much, all studies done worldwide say the same, that 100 miles range, give or take, is sufficient for about 95% of all driving patterns. So you would be forgiven for producing EVs with sensible battery packs, so of that 100 miles range, which is what many OEMs have done. So there are about 10 plus vehicles available which cover that typical range, but they have not been very successful in the market. It's even so that on a global scale, less than 1% of all mid-range vehicles are electric cars. And compare that, for example, to the Tesla Model S, which single-handedly hits 8 or 9%. of the tier that it is operating in, so the luxury vehicles, it indicates a couple of things. First of all, range anxiety is real, which is of course why a big battery, hugely overdimensioned battery pack, together with the supercharger network, is the solution for that. So Tesla very accurately foresaw that. But you can conclude that people are willing to pay a huge premium for that 5% of their driving needs. So in this case, tens of thousands of dollars. But there's another issue. So it seems that people consider their vehicle as a durable good still today. It's an investment which they expect to be able to cover every foreseeable scenario in terms of driving range. And the premium, as I said before, that they're willing to pay is absolutely disproportional. So we think that this inefficiency, so the fact that in a Tesla Model S, 90% of the battery capacity goes unused on a daily basis, this opportunity is where we will introduce new efficiencies. We think that the 100 miles of range, which has been quoted by other manufacturers as sufficient for 95% of all driving trips, we think that's rather good, so we also use that as a recommendation. Or in other words, what we do is we say that people should decide for themselves what are their typical driving patterns, and they can supplement the capacity that is needed for that with a large margin, let's say 200 or 300%, not a ridiculous margin like the 9 or 10 times as you, for example, have in a Tesla Model S. But when necessary, such as the typical road trip, of course, capacity can be added for as long as the user so needs, and this essentially ends range anxiety. And of course, there's also this fact that charging a car and waiting for it to charge is no longer necessary, because you can get a new load of freshly charged cells in a matter of minutes if you so choose. And it means that the range anxiety goes away, but also the fact that you have to think or plan your trip, like has been the case before. We eradicate that, so that peace of mind is an important part of the value proposition. Here you can see how the Tanktwo string cell stacks up against the industry standard 18650 lithium ion cell. So the Tanktwo string cell is approximately the same size and the same weight, and therefore also the capacity is about the same. The Tanktwo string cell is a little bit shorter, a little bit fatter than the standard cylindrical cell, but since it's made of essentially the same stuff, the power output is comparable with the 18650. The only delta or the difference between the two cells is that the Tanktwo string cell includes a chip, a little piece of electronics, which is necessary to make it smart to let it do the communication and the switching. And that results into an incremental cost of initially about 20 cents per unit, but we expect that to erode to 10 cents or to essentially zero over a short period of time after an initial amount of critical mass has been reached. Look at the benefits of the Tanktwo string battery. Most important being that the tank capacity is variable, meaning that the sticker price of the electric car can be decoupled from the price of the battery. It will make the electric cars much more affordable. So you'll drive around with the capacity that you need on a daily basis with 200 or 300% of margin, but not the 700 or 800 or 900% that you never use. And a full cell swap, meaning that if you run out of charge and you replace the cells in your string battery with freshly charged one, that process takes approximately 60 seconds. In public forums we say about 3 minutes. But the current estimate is that we can do it a lot faster than that. It's literally faster than buying gas. The cells still also work much longer, so down to approximately 10% of their design capacity. In a traditional battery pack, the strength of the weakest link essentially determines the strength of the entire battery pack. Not so in ours, so very strong cells and very healthy cells can work alongside very weak and end-of-life cells, and the sum of the entire battery pack is exactly the capacity that you get, which is not true in a traditional one. Traditionally, a battery pack is considered at end of life when the capacity has deteriorated to 70 or 80%. Not so in case of a Tanktwo string battery, because the cells themselves, they can contribute even when they only retain 10% of their original design capacity. So many more cycles can be extracted from a Tanktwo string cell, and therefore the cost over the duration of the life cycle of the product goes down. Also, repair or restoration of the pack capacity is now very easily done, and it's like literally performed in minutes. Also, the cells are pushed harder, which means that they can be designed to fail. But because of the fact that there are always billions of connections available, every bit of electricity or capacity can always be extracted from the system. And of course, there's the intrinsic safety. So no more battery fires. That's a very good thing. And the way that it works is that the Tanktwo string battery, so the container, the tank if you will, it has pyrotechnic actuators, essentially things that you also find in an airbag, which in case of an accident or other dangerous situation, rupture the container so that the string cells are dispersed on the street and thermal runaway is no longer possible, making the Tanktwo battery the only intrinsically safe system on the market right now. It's no surprise that the electric car industry is evolving very rapidly, and Faraday Future, for example, announced a modular battery system at CES in 2016, which will certainly allow certain improvements in the system and certain flexibility that is very desirable for automotive designers. And we really think that it's obvious that everybody will eventually end up in the same place where we are going. So intelligent, flexible, distributed batteries, they're the way to go. They're more efficient, they're safer, and they will save everybody money. Also, the smartness or the intelligence is necessary. So batteries need to be able to change from one owner to the other in an intelligent way. Pretty much they should be like shipping containers. They should be carriers of energy. Battery packs should be repairable easily and cheaply. Billions of connections are necessary. Always the last drop of power should be extractable from the system. And then of course the customer expectation is that you can get a tank load of electricity, so the pumpability. We think that the consumer will be really excited to see that. Since Tanktwo is a technology licensing business, we have hired one of the world's best IP firms to help us with the protection of our IP. The technology which has been described here has been patented by us extensively, and we can enforce it if that is in our interest. So far, Tanktwo has the only solution that covers the needs of the governments, the automotive manufacturers, and the consumers. Consumers, in the end of the day, they have to pay the bills, so they'll be interested in the reduced price. The governments have here the ability to get rid of the subsidies while still meeting their international obligations. And the OEMs will certainly appreciate the ease of implementation and the low threshold and the low risk that a Tanktwo string battery provides. The key technology partners which Tanktwo is working with for the introduction of the string battery system is Valmet Automotive, which is an automotive design and manufacturing house which has been manufacturing the Fisker Karma, several Mercedes-Benz and Porsche products. They work with the automotive side of our solution. Then there's Zeppelin Systems, which is the global leader in bulk handling of solids. So they work with us on the infrastructure side, the pneumatic conveying of the string cells in and out of the container. We're working very hard towards the 2017 global launch effort. If you're potentially interested in being one of those launch partners, we'd like to hear from you. For example, if you work in the energy retail, or you are a data science company, or even if you are an OEM, but you have to be quick because of the turnaround, we'd like to hear from you. So my email address seen below here, b@tanktwo.com. My phone number is 212-321-0630. Looking forward to hearing from you.